Next up is a talk by Yutaro Hayakawa.
Hello, this is Yutaro Hayakawa from Line Corporation. Today I'm going to talk about the very overview of how we use the eBPF in our private cloud infrastructure. I cannot introduce in detail, so I put many pointers in this slide. So if you have interested in, please visit those links. If you may don't know about the Line, so let me explain it first. Line is a messaging service which is very popular in Asian countries like Japan, Taiwan, or Thailand. It provides a lot of family services around that messaging functionality, like video streaming, news media, music, and so on. We have approximately 185 million global monthly active users and over 3 Tbps of network traffic in total. Many of the Line services are running on a private cloud called Builder. It is based on OpenStack and provides the basic cloud functionality like computing, networking, storage, as well as the managed services like Elasticsearch, Kafka, Redis, or Kubernetes. Here is the place which eBPF comes in. Since about 2017, the very beginning of our service, we provide the XDP-based high-performance L4 load balancer service. It already has 5,100 private and 760 public VIPs and be deployed in 3 regions in global. The number of users are growing even for today. We are also developing the integration with other cloud components. For example, recently we have developed the integration with our managed Kubernetes service using Cloud Controller Manager. That means if users create their service with type load balancer, it uses the XDP load balancer as a backend. The very simplified service architecture looks like this. There is a user-facing API server. Users can configure their load balancer from dashboard or using API or indirectly use it through Kubernetes. Once the API server gets the request to deploy the load balancer, it configures the actual load balancer instances through RPC. Here we have VCC-based load balancer control plane, which is responsible for interacting with the API server and configure the XDP data plane through the eBPF maps. Our data plane is inspired by many hyperscaler architecture like Google, Microsoft, and Facebook. It uses IP-based L3 DSO, maglev hashing, or LRU map-based session caching, and so on. Here we don't have enough time to explain about the entire service architecture. For more information, we have a presentation that describes it in detail. Please check it out if you have interested in. So let's go on to our next use case. The next one is a tool called IPF Trace, which we have developed recently. It is a domain-specific function call tracer. It traces which packets have gone through which functions inside the kernel. The usage is very simple. Mark the packet you wish to trace and pass the mark to the IPF trace. That's it. What you get is like this. What you see in the middle column are the functions that the packet have gone through. This trace is very useful to see how the packet have processed in the kernel. In addition to the function code trace, users can write the small script to correct additional data from skbuf with Lua. The information on the right-hand side is corrected by that script. This is very useful to see how the fields of skbufs are changed function by function. For example, here it tracks the GSO information. So how we use it? We use this to investigate the performance issue on the hypervisor in our next generation data center network architecture. It heavily utilizes the quite younger Linux kernel feature like SRv6 or VRF. We met the very weird performance degradations when we used the GSO together with this hypervisor network. We applied the IPF trace to investigate this issue and found there was a bug in the GSO handling in the SRv6. We got a dramatic performance gain in fixing this. We upstreamed the change and it's already a part of the mainline kernel. Again, we don't have much time, so here are the pointers to the detailed information. We have more and more eBPF stuff to talk. Here we have another use case of XDP for SRv6 data plane acceleration and how we use the UDP and PathMT discovery in our load balancer. We very quickly went through our eBPF use cases. If you have further questions, please feel free to contact me on Twitter or Slack. We are very happy to interacting with the eBPF community. Thank you for listening, and now I will take a question.
Thank you, Yutaro. Awesome. I think another great example on how eBPF at the edge is changing load balancing and